Hi Year 12s. This is a video to explain how to sketch the logarithmic function. A logarithmic function is used to better model functions which increase at an exponential rate. It is the inverse of the exponential function, and the general equation is f of x equals log base a x. The two main log functions that are used in methods is log to base of Euler's number, the natural log, and log to base 10, where every time x increases by 1, the function increases by a factor of 10. We don't have time to cover our logarithmic laws here, but it is important to know them for math methods. If you need reminding, they are included in the logarithmic and exponential law video, under the algebra heading. Here are a few guidelines to sketching logarithmic functions. Number 1 is that the log of 1 to the base of any number is equal to 0, as this is the inverse of the rule that any number is to the power of 0 is equal to 1. Number 2 is that log of the base a to the base a is equal to 1. Number 3 is that we can't take a log of a negative number, or of 0, since any number to the power of another number cannot equal 0 or a negative number. You just get smaller and smaller fractions. Remember here that our exponential functions were never negative. Therefore, the domain is only real positive numbers. Number 4 is that as x approaches 0, the function approaches negative infinity. Number 5 is that the range includes all real numbers, which means the function can equal anything. Number 6 is that it is a one-to-one function, which means that every point on the x-axis corresponds to one, and only one, point on the y-axis. If we represent the logarithmic function in the form of y equals the log of x minus h plus k, then we can see how the function shifts along the x and y-axis. The rules of sketching this function are similar to the exponential function. In this equation, h represents the shift along the x-axis, and k the shift along the y-axis. The graph can be reflected in the x-axis by placing a negative in front of the function to get f of x equals negative log x, and the graph can be reflected in the y-axis by placing a negative in front of x in the function to get f of x equals log negative x. Since we can't have the log of a negative number, then all the values of x for this function must be negative. Here, we can see a number of natural logs graphed. Increasing the value of the base will cause the function to increase at a greater rate for values of x greater than 1, and decrease at a greater rate for values less than 1 but greater than 0. Here we can see the green function is a reflection of the blue function in the x-axis, and the red function is a reflection of the blue function in the y-axis. It is also possible for a log function to be reflected in both the x and the y-axis, if the negative is applied before the function and the x value. If there are translations applied to the function as well, you must first reflect the function before you translate them. The effect of dilation is similar to what happened with the exponential functions. If there is a value k in front of the function, the dilation factor will be k from the x-axis. The value will just be multiplied by k. If there was an x coefficient to the value of k inside the log brackets, then the dilation factor to the y-axis will be 1 over k. The x coefficient will be multiplied by 1 over k for a given value. Let's now look at an example, such as the function f of x equals negative 3 log 2x plus 5 minus 3. Which we can rewrite as f of x equals negative 3 log 2 times x plus 5 over 2, take away 3. Straight away, we can see that there is a reflection in the x-axis, a dilation by a factor of 3 from the x-axis, a dilation by a factor of a half from the y-axis, and a shift of the graph 5 over 2 to the left and 3 down. At this stage, we need to have the shape of a negative log in our mind, and from there, we know it will have both an x and a y-intercept. A y-intercept due to the fact that there is a shift to the left. This means our asymptote will be moved from 0 to x equals negative 5 on 2, or 2.5. Now we set x to equal 0 to find our y-intercept. This gives us f of 0 equals negative 3 log 5 take away 3, and so that is our y-intercept. Then, to find the x-intercept, just set y to 0 and solve for x. It's important to know these basic graphic functions, as soon we'll be moving on to composite functions, which are combinations of different functions that we may need to graph. Until then though, happy studying!
Click here to try and find the Engage Wiki, or click here now to see the next video. And now I need my broom.